The BSides NoVA 2019 presentation will begin momentarily. 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 The BSides NoVA 2019 presentation will begin momentarily.
We'll do our best to move this along and, more importantly, keep it interesting since it's late in the day. Today we're going to talk about Hanlon's razor and BGP hijacking and look at some of the things that we're seeing in terms of BGP hijacking and whether any of it can be attributed to malice as opposed to just incompetence. And we're having clicker technical difficulties occasionally, so if you see a little hesitation, that's what's there. Before we get started, a little bit about us. My name's Allan Liska. I'm an intelligence analyst at Recorded Future. I've got 15 plus years in experience in security, and this is how you can get a hold of me if you'd like to. Oh, that's weird. Let's try. There you go.
Can anyone hear me? No? Okay, I'm Bruce Liska. I'm a data analyst. I work on a lot of sports analytics. So if you need help with your fantasy football teams after this, I know what you need to do.
And pretty much everybody in the family asks him for help with this fantasy football, and his grandfather really hits him up for the basketball daily fantasy. No, completely unrelated. I was looking for a research assistant, and he answered a Craigslist ad. All right, I think we're going to have to do this the hard way. So, oh, there we go again. All right, so this is our agenda. First, we're going to start off talking about rampant BGP incidents. Then we're going to focus on BGP hijacks, discuss Hanlon's razor. Bruce is going to take a look at the data, and then we're going to talk a little bit about stopping BGP hijacks since it is a security conference. So the Internet Society takes a look at routing incidents, and they define a routing incident as a BGP leak, an outage, or a BGP hijack year over year. So Andrei Robochevsky looked at routing incidents in 2017 and 18. Some of his findings include that in 2017 there were almost 14,000 incidents. That number dropped to 12,600 in 2018. Over 10% of all ASNs were impacted in 2017. Much fewer, about 4.4%, were impacted in 2018. 1,546 ASNs caused at least one incident in 2017, while 1,294 were responsible for an incident or more in 2018. And there are a lot of security incidents that happen in a given year. We tend to think of the internet as relatively stable and operating, and I need my Netflix, I go get my Netflix, it works just fine. It turns out the internet's a big mess, right? It's kind of held together with duct tape and baling wire, and it kind of just works based on hope and prayer. And for the most part, the things that go wrong are invisible to large swaths of the users, but every now and then you do notice when these things pop up. And one of the things that you notice is BGP hijacking. So we're going to step back and define some definitions for those of you that aren't familiar with networking terms. BGP is the Border Gateway Protocol. It's the protocol that networks use to get from one place to another. So back in the old days, old days of the internet, you basically had a routing table. You threw the routing table up on the router, and if I wanted to get from point A to point B, I would follow everything in my routing table. Well, when your routing table includes billions and billions of IP addresses, IP4 and IPv6, you can't do that anymore. So the way we do it is with Border Gateway Protocol, and that manages how traffic gets from one autonomous system, what we call an ASN, or one autonomous system, which is what we call a network, to another autonomous system. And then BGP hijacking is the illegitimate takeover of IP ranges by the corruption of BGP routing tables through announcements. So you say, yes, I own this IP block, I announce it to my peers, who then announce it to everyone else's peers, and suddenly everybody is routing through them. This is a diagram of what it looks like. That's a meme of what it looks like. So depending on how you prefer to digest your information, you can have it in diagram form or meme form. And there's a lot of BGP hijacking that goes on. These headlines were all taken from 2018. It's just a sample of what some of the things that happened were, but there are BGP hijacking incidents that are happening all the time. Most of the time, most people on the internet don't know them unless you are locally affected. You don't actually see what's happening. Now, Hanlon's razor comes into this because, first of all, Hanlon's razor define it as never attribute to malice that which can be adequately explained by stupidity. In security, we're all familiar with Hanlon's razor for various other things. We may not call it that, but that's the term. And the reason that we talk about BGP hijacking and Hanlon's razor is that most BGP hijacking incidents are accidental. So even though you have the big scary headlines, most of the time what happens is you're sitting in your network, it's 3 o'clock in the morning, you're making an update, and you put in the wrong IP block, and suddenly you've hijacked somebody else's network. Most of the time it's an accident. When that happens, they're usually fixed pretty quickly. They happen infrequently on well-run networks because the network engineer that made that mistake generally doesn't make that mistake a second time. I know back in 1997, I took down all of Chicago at the ISP that I worked for. I was very proud of myself. Took it down so hard they had to fly somebody out because we didn't have remote hands at that time. They actually had to charter a plane and fly somebody out to go and manually reset the router. So I've been there, I've done that. On the other hand, there are definitely some networks that have an inordinate number of these hijackings, and they go on for a much longer period of time, even when somebody reaches out to them and say, hey, you're hijacking our traffic. And they're like, oh, yeah, we'll get to it. And they don't. So what we wanted to look at is whether or not it's possible to draw any conclusions as to which networks are making honest mistakes and which are acting maliciously. So just a quick understanding of the data set that we used. We took a look at all identified BGP hijacking incidents that we could find from August 1st to December 31st of 2018. We used a combination of the data sets available from the Center for Applied Internet Data Analysis. So they have a program available called BGStream that you can download and run yourself, and there's up to 15 years worth of routing information announcements that are available that you can query and run. I will tell you that whatever the size of your system you have, it's not big enough to actually run any big queries against it. But it is there and it's available. Make the data BGP Stream website, which is a really cool little resource in the internet. So 2 very cool tools from CADA. We love it, and there's a lot of valuable information that you can learn from there. So we got the data, and then Bruce crunched the numbers.
So during that 5-month period, the results showed that there were 1,054 reported BGP hijacks, and they're originating from 478 different ASNs. And of those 478 ASNs responsible for a hijack, only 322 were responsible for one hijack, and 416 were involved in 1 or 2 hijacks. Of the top 21 ASNs during that 5-month period, 9 of them did not hijack any networks during that time. In August of 2018, there were 86,510 registered ASNs. As of January 1st, 2019, there were 89,250 ASNs, and it's approximately less than 0.56% of those ASNs engaged in hijacking activity. Of the ASNs responsible for a BGP hijack during that period, the average ASN was responsible for 2.2 hijackings, which if you go back to the other slide, whatever, I think it was 416 were involved in 1 or 2. That's about normal. And the top 15 offenders of hijackings accounted for 351 of the hijackings, which is about a third. So to look at it at like a country level for hijackings, United States was involved in the most hijackings, but that's probably because they have the they have the most ASN percentage in the entire world. If you go down the list, Brazil, Russia, Netherlands, Hong Kong, Britain, India, and Germany are all on the list of the just for a pure number of hijackings. So to look at the worst offenders of hijackings during this time, there is a company in Poland which I can't pronounce, my dad can't pronounce, so we'll just leave it at a company in Poland. Had 66 hijackings.
Oh, please do.
Yes, please.
Very nice, thank you. We've been struggling with that. For 3 months, we've been trying to figure out how to pronounce that, so that's impressive.
Followed second closely by Tata Communications, and a whole bunch of other companies in the United States, India, and places like that. And there's one company that's on there twice, level 3, under 2 different ASNs.
And you'll see in here that the worst offenders are pretty widely distributed by country, so a number of different countries are represented. So we looked at some of the victims of, we're going to call it AS 50607, unless you want to come up on stage and help us pronounce it every time, during that period. And what you see is they're sort of an equal opportunity attacker. And so, again, there's a lot of activity, there are a lot of targets. These aren't quite as high profile targets, but it's a completely different target profile if they were targeted. So what we thought we'd do was, we're not finding anything specifically in the attack data, or in the hijack data, so what we did was look at some of the victims.
So there were 740 hijack victims during that 5-month period, and of those victims, 525 were hijacked once, and 691 were hijacked once or twice. And on average, organizations that were hijacked 1.42 times. So once again, 691 of the 740 were about normal. So these were the top victims. Once again, the United States heads to the top because they have the most ASN space out of everyone in the world. And then most of the same countries or places are on this list that are the same as the last one. Brazil, India, China replaced Hong Kong, Germany, UK, Netherlands, and Russia are all on this list. Interestingly, Russia was hijacked, or was a victim of hijacking 2.5% of the time, versus they were they were the ones hijacking, I think it was about 7% of the time.
2.7%.
Yeah.
So you'll see if you went back up, third or fourth, but the numbers aren't actually all that different. So where they rank is interesting, but in terms of their percentages, it's actually fairly the same. Not working?
Nope. Should I go hit spacebar?
Yeah, thank you. Just spacebar.
Here are the top victims of hijackings. You see a lot of very popular companies such as Amazon, Multicom, T-Mobile, and the victim of hijacking, one of the victims of hijacking, level 3 was also a part of, I think it was third most amount of hijackings if you added up the 2 separate ASNs they had.
So the U.S. is very much overrepresented there in terms of the victims of hijacking. But more importantly, what we see is for almost all of these victims, these are all content providers. So when people think Amazon at first, they're probably thinking, oh, well, why do I care what books somebody's trying to read? But Amazon's responsible for AWS. Multicom is a hosting provider. Cogent Communications has data centers. ZenLayer is a hosting provider. Level 3 also a hosting provider. So what we're seeing is companies that specialize in hosting content are getting hijacked more often to hijack. Looking at this data, we figured, okay, this was going to be easy, right? We're going to run these numbers. It's going to turn out that Russia and China are definitely doing all kinds of bad things and creating all kinds of problems and ruining the internet. Obviously, that's not the conclusion we came from looking at that data. Admittedly, it's a small subset of data. It appears that the hijack factories, what they call the hijack factories, may have certain targets, but we're not really sure what the pattern is based on the initial search. And the other thing that we're seeing is that the bad hijacks, the ones that make the news, don't happen as often as the news portrays. Most of the attacks we're seeing are small attacks that don't impact, that impact some people, but not a lot of people. So what we're hoping to come with were some sort of conclusion that, hey, this is bad and here you go, blame these people. We don't really have those kind of conclusions to come to from doing the analysis. Instead, what we wanted to look at was what companies can do to protect themselves from BGP hijacking. You as an individual user most likely can't do anything unless you happen to have your own Class C and your own AS and everybody routes to you, in which case kudos to you. So instead, while BGP hijackings are common, although they appear, for at least from 2017 to 18, to be going down, they don't have to be, and there are more steps that organizations can do to protect their customers. In February of 2019, AT&T announced it would start dropping route announcements that were not validly signed with RPKI. They're doing this to external networks at first, but by the end of the year they plan on having even their own internal customers dropped if they don't do it. Which is funny because APNIC, AFNIC, LACNIC, RIPE, and ARIN, the registrars, the internet number registrars for all the different regions, have been offering RPKI services since 2011. So the solution's been there the whole time. very few people have wanted to implement it. And RPKI allows network operators to verify whether an IS is actually authorized to announce a prefix. And so that combined with BOA or ROA, and you're able to better protect against those kind of routes or those kind of attacks. The other thing that the other thing that we found, there we go, are a whole bunch of resources for figuring out what you can do to protect your network against BGP attacks. These are some really good resources. They lay it out in easy to understand language about what needs to be done and how you can protect yourself. And again, we thank you all very much for your time. We do apologize for the technical difficulties, but we're happy to take any questions if you have any. And again, thank you all. Any questions?
You actually look at like which prefixes it was, like was there a lot of like one down, one side, or
So remember 1.1.1 is now owned by Cloudflare. Oh, sorry. You asked if we looked at what prefixes it was, and you mentioned 1.1.1 specifically. So 1.1.1 is now owned by Cloudflare. So had it been that, it would have shown up as a Cloudflare ASN. So what we didn't see were any prefixes that looked like they were somebody mistyping an RFC 1982 address, so nobody like 193.198 or whatever instead of 192.198. There didn't appear to be any commonalities in those in the prefixes that were announced instead. And what we didn't see is any sort of similarities. So in other words, if I'm 101.100. Whatever, and I accidentally type in 102.100. Whatever, then that could be chalked up to a mistake. And we didn't see anything like that, any sort of close routes. What we haven't looked at, and is sort of the next phase of what we'd want to do with this, is start looking at duration of the attacks. So when did the attack start? When did it stop? Because that would give us a better view as to whether or not this was probably an accident or whether it was malicious. So for example, when China allegedly hijacked Google traffic, it was for a week. So it was a longer duration attack, and that's sort of the next phase of what we'd have to look at to see if we can build any patterns from there. Yes?
What's the best way to get alerts or notifications every time China does a BGP attack?
So there are a couple ways to do it. The question is, what's the best way to get alerts or notifications every time China does a BGP attack? There are a few ways to do it. So you could use the Kata database, and you could download that, and you can run a script and just have a Python send you a note. There are a ton of services out there that will also do it for you. I think Thousand Eyes, BGP Mon, and a few others, which will make your life a lot easier. It's going to cost you more money. Also, so one of the cool things that the BGP Stream website does is they also have a Twitter feed. And so you could, for sort of a ghetto way to do it, you could write a Python script that checks their feed, because what they do is they give you the AS and the 2-letter country code associated with that. So if you wanted to monitor for all China activity, you could write a script that using the Twitter API that queries their feed for every time the word CN or the 2-letter phrase CN is mentioned, and then just have that alert yourself.
I'm doing the manual database way with some scripting, and it also calls the Twitter accounts.
Yeah. And to me, that seems to be the most effective way if you're trying to specifically track a certain country or whatever. We haven't found a more effective way to do it. No, you're not. No problem. Any other questions? Oh, yes, sir.
Did you guys look at the one online service in Nuremberg? Sounds like a small ISP or hosting company. Did you at all look at how many prefixes they're announcing, and if the ones that they were announcing legitimately were like off by one, and somebody fat fingered it? And for like this online Nuremberg, they sound like a small hosting company who's upstream
Great question. So the question is whether or not we looked if the small companies like Nuremberg were just accidentally announcing things that are one-off, and then whether or not their upstreams are filtering. So the answer to your second question, yes. Upstream should be filtering for mistakes like that. To your first question, no. We looked at the we looked at the hijacking incidents that were reported, and we looked for exactly that, because that was another pattern that we were looking for, and we didn't find that in any of the top hijackers that we saw, where it was just, this is a one-off network, or this is a, this is something that was easily mistyped or whatever, the numbers transposed or whatever. We didn't see any behavior like that in the data that we looked at. And again, we only looked at the data for those top offenders. My guess is for the ones and twos, we would probably have found more of that. Any other questions?
Yeah.
Oh, yes.
It seems like some of the BGP errors or attacks simply create outages and others create two-way traffic that can go unnoticed. What is the difference in those circumstances?
So the question is, some BGP errors create outages versus one cause redirection of the traffic. I think the redirection of the traffic is based, and I'm not a routing expert, but as I understand it, is based on the number, on the prevalence of the number of other AS that pick up on the routing announcement. So specifically, when we looked at these, what we did was we looked at what appeared to be hijacking incidents that were announced by at least 100 other ASs. That way we knew it was more widespread. So we weren't looking at the, I'm going after my local, or I'm accidentally typing in, my next door neighbor, or my next door network, I should say. So we would look for things that were more widely announced in order to have a better understanding of a true BGP hijack versus just a temporary blip in traffic. No problem. Any other questions? No? Again, thank you guys very much for your time.